different perspective on this trig function of an angle equaling a ratio. Day one, given the trig function, given the angle, finding the ratio. For all triangles that are created with a base angle of 60 degrees, no, come find a seat. Who's got an extra seat? Oh, really?
Yeah.
All right, yeah, all right, cool.
My friend just like.
That's going on YouTube, everybody. Going on YouTube. We won't say who got sprayed with fart spray. Cool. All right. Yeah. Welcome back, Lake Travis High School. All right, great. So every single triangle that has a base angle of 60 degrees has a, I can smell it. It's the cologne though, so that's good. Has a ratio of opposite to hypotenuse, which is root 3 over 2 over 1. You know, so this is like every 30, 60, 90 triangle, this tall orientated opposite to hypotenuse has this kind of ratio. That's why trig functions were invented. So, you know, similarity of triangles, no matter how large your triangle is, if the base angle of this right triangle is 60 degrees, this is the ratio of the opposite to the hypotenuse. Okay, cool. Here's day two. Day two is we have the trig function, we have the ratio, but the question is, what is the angle? Okay? And we need to somehow kind of reverse engineer kind of our understanding here to get the answers to the angle. Okay? We need to somehow get to the point where we know, okay, the sine of pi over 3 is root 3 over 2. We already kind of know that from this part. But we also need to know that the sine of 2 pi over 3 also produces a ratio of root 3 over 2. So we end up seeing that there could be two angles. There could actually be more than two angles. If I wanted to, I could go around in the other direction and find out that negative 4 pi over 3 is a possible solution. Negative 5 pi over 3 is possible solution. This is like going around the opposite way, arriving at the same location. But like if I asked you what is the sine of negative 4 pi over 3, you would say it's positive root 3 over 2. We could also continue to go around the circle over and over and over again to get to like maybe 7 pi over 3. If I asked you on your quiz today, what is the sine of 7 pi over 3? You would say it's root 3 over 2. You would have been able to figure that out. Okay, so we got to figure out how to get all of these answers. And I'm going to tell you the way that I do it, okay? Two different approaches, and I'll show you this approach, which is my approach first. Cool? This is like reverse engineering so we can find the angle so that the trig function of the angle equals the ratio. All right. I start with my three triangles. Well, honestly, it's right, two triangles, right? I have a tall 30, 60, 90 triangle. I have a short 30, 60, 90 triangle. And then I got my 45, 45, 90 triangle. Start with my triangle. Okay? And I know the side length of these three triangles. Why don't you go ahead and label the side length of the triangle? And I'm writing these down, but these are kind of like in my head. And you guys have them down. Or obviously you can write them down if you don't remember them, or if they're not in your head yet. Yes, I think I did. Yeah. Cool. So we got the tall 30, 60, 90. Base angle 60 degrees, that's the pi over 3. We got the short 30, 60, 90. Base angle, reference angle 30 degrees, those are the pi over 6 angle. We got our 45, 45, 90 with root 2 over 2. Okay, so that's the first thing just like I have in my brain is these triangles. Cool. Now, I'm going to pay attention to the trig function that I have and my value, but I'm actually not going to care about the negative part of it. I'm just going to say, okay, sine, which deals with the opposite over the hypotenuse or the vertical side length. You guys sometimes keep going and you say it's the y length. That's fine. Okay. When is the opposite or the vertical length equal to 1/2? That's what I'm going to start with. I'm going to pick my triangle. So I look at my 3 triangles and I think, when is the opposite side going to be 1/2? And I find my winner. Okay. That triangle, the short 30, 60, 90 triangle, which occurs at the pi over 6's, the sine of the angle equals 1/2. Now, I need to pay attention to the fact that sine could equal this negative 1/2 in multiple locations. And this is where I break out this mnemonic, all students take calculus. ASTC, all students take calculus. It's a mnemonic, however you spell that. And I'm going to, on my little diagram, write down that ASTC. Now, it goes from first around to fourth. So A is in the top right, then S, then T, then C. Now, what this mnemonic is telling me is which trig function is positive in which quadrant. So it's for positive trig function. What do I mean by that? Like the A stands for all. Every single trig function, sine, cosine, tangent, and the reciprocals are positive in the first quadrant. S stands for sine. Sine and cosecant are positive in the second quadrant because I'm going up in my y direction. Sine stays positive. Tangent is positive in the third quadrant because we got negative x's and negative y's, so negative verticals, negative horizontals. Cosine is positive in my fourth quadrant because I'm going right, but I'm going down. So sine is negative in the fourth quadrant, but cosine is positive. Cool. Now, all I need to do is combine my knowledge of this triangle and this being my trig functions that are positive to know that sine will be negative in the third and the fourth quadrants. I just need my pi over 6 angles in the third and the fourth quadrant. As long as I have this pi over 6 and this pi over 6, I know those are the locations, 2 locations, where the sine value will be negative 1/2. And tell your neighbors, what are those locations? What are those pi over 6s? Good. And hopefully we can do this without like writing out the whole unit circle with all the angles. We have 6 pi over 6 plus a pi over 6. We have 12 pi over 6 minus a pi over 6, and boom. Now, right now we're going to stop right there and we're going to say these are my angles between 0 and 2 pi. These are all of my angles between 0 and 2 pi. There are an infinite amount of angles where the sine equals negative 1/2. They will all end up at those locations, but they'll be different angles. Whether you have negative pi over 6, that is a solution, but negative pi over 6 is not between 0 and 2 pi. Cool? This is what I do. I start with the triangle, I figure out which type of triangle, and then I go to the quadrants with those triangles. The other way you could do it is by starting not necessarily with a triangle, but starting with the length. Like if you said, okay, cosine's adjacent, and the adjacent is negative root 3 over 2. You could kind of just go to the left, this negative root 3 over 2 first, and then you can kind of create triangles off of this length, like that. This is a different question. and your answers are 5 pi over 6 and 7 pi over 6. The only issue I have with drawing the length first is it's tougher with like the sign of negative a half. A lot of people try to, or sign of x equals negative a half. A lot of people try to say, oh, okay, I want to go down vertically a half. And if you go down a half, you might try to make a triangle like this or like this, but that's not what we want to do. So it works, my bad, but it might not be the right approach, and it's not something I would recommend if you're kind of relearning this from the start. I'd kind of start with triangles first, then ASTC, and then angles. Okay? If you were to do it this way with drawing the lengths, what you would have to do is understand that to go down, you have to go down to the sides here, not on the x-axis, and your angles would be created like that. Cool, so let's try it. You guys tell me, what are the angles that are between 0 and 2 pi, where cosine of the angle equals root 3 over 2? Recommendation, start with the triangle. Start with all 3 triangles maybe in your head. Pick the right one. Which triangle has the characteristic we're looking for? Then, using ASTC, draw that triangle in the correct quadrant. Cosine deals with what? Adjacent. So which triangle? Yeah, because the adjacent or the horizontal is that longer side. So, you know it's the short. Good. You drew the short in this quadrant. Good. You know it's a pi over 6, right? Cool. 2 pi can be written as 12 over 6 pi. Subtract 1, 11 pi over 6. If we are able to do that where it's like we're not memorizing these locations, rather we're finding it by using like 12 pi over 6 or 6 pi over 3, it'll be easier. Okay? Now, you're missing one other one. Yes, cosine is positive here, but cosine is also positive. Yeah. Good. Triangle first. Which triangle has the adjacent side or the horizontal side equal to root 3 over 2? Well, I know it's either the short or the tall 30, 60, 90 triangle. I know root 3 over 2 is the longer side. This is not working out. There we go. Root 3 over 2 being the longer side. So there is my root 3 over 2. It's going to be at my 30-degree short pi over 6 triangle again. Okay? Now, I know I need the pi over 6s. I need the 30-degree reference angles in the first quadrant and the fourth quadrant because of ASTC. I'm moving to the right in both situations. Now I just need to know that angles. Well, I'm starting at 0, add a pi over 6. You get pi over 6. I could say the answer is negative pi over 6. That works. However, negative pi over 6 is not between 0 and 2 pi. So instead, I go all the way around to 2 pi. Same location as 0, only this can be written as 12 pi over 6. Remember, adding is this way, subtracting is that way, counterclockwise versus clockwise. Subtract 1 pi over 6 from 12 pi over 6, and you get 11 pi over 6. Cool. This guy. Start with the triangle. Figure out the correct triangle. Then ASTC, locate where those angles are. Coming from the middle out. That's crucial. Nice. Find the correct quadrant. Always making our triangles with the x-axis. Honestly, you don't even need the triangles. You just need your rays. You just need your angle. Nice. Nice. Some of us, like, this is a piece of cake. Some of us, it's like, whoa, this is tough. It's like, yeah. If it didn't go well last year, I could see how, like, it's still tough. We just got to figure it out. And if you're struggling, that's okay. We're allowed to struggle. How are we doing over here? Is it a struggle or is it easy? All right. It's okay if we're struggling. Learning is all about the struggle. All right. I start with my triangle. It's the 45, 45, 90 triangle. That's a pi over 4. I can skip through my triangles now. I don't have to draw any more triangles. If I know I'm going to be at the pi over 4s because the opposite is root 2 over 2, then I'm good. I'm just going to stay there, pi over 4s. When is sine negative? Well, sine's positive in the first and the second quadrant. Sine is negative in the third and the fourth quadrant. So I just need my pi over 4s here and here. You don't have to draw the triangle. You can just like draw the rays. Just be like, those are the angles that I want. Find. You know that those are pi over 4s. You know that those are pi over 4s. You just got to find the right amount of pi over 4. This is where we go 4 pi over 4. Subtract, add 1 pi over 4 to get to 5 pi over 4. Not something I've memorized. I figure it out. We go 8 pi over 4. Add, subtract. You could say this is negative pi over 4, sure, but that's not between 0 and 2 pi. So instead, we'll go all the way around to 8 pi over 4, subtract the pi over 4, and we realize it's 7 pi over 4. So 5 pi over 4, 7 pi over 4. Now, if we wanted just our solutions from 0 to 2 pi, boom, that's it. If we wanted all possible solutions, we could say, well, these are the locations where sine is going to be negative root 2 over 2. Any other angle that hits that location would also give me a solution. This is the concept of adding multiples of 2 pi. N stands for like an integer. N times 2 pi would be like multiples of 2 pi, which just means like you'll end up at the same location, just at a different angle. Very important to understand, like 0 and 360 degrees are 2 different angles. They just happen to end up in the same location. If I'm on a skateboard going straight, I'm going 0 degrees. You know, I'm just going straight. If I pop a 360, I'm really cool, that's the first thing, but I end up going in the same direction as just 0 degrees. But obviously I did something a lot cooler than just going straight, okay? So understanding that going around the circle takes you to different angles, but they happen to bring you back to the same location. This is all solutions. We will focus on 0 to 2 pi. However, there's going to be some questions where we might have to incorporate this to get all of our answers. Cool. Let's go to this one over here on the right. Secant equals -2. Tell your neighbors, what would be the first thing you would do before maybe even thinking about triangles or ASCC? What would you do? Nice block, Miller. That's what I would do. Oh, careful. Good job. That's the one that I would use. But if I'm going to use this, that's going to change too. That's what I would do. That's what I would do. I would change the question to that. If you're ever dealing with a reciprocal function, don't deal with it. Change the question. Secant equaling -2 is the same as cosine equaling -1/2. That's where I would start. All right, good. So I just changed the question. Now, let's go to your triangles. Let's go to your radian, and then let's go to the location of said radian. Very nice. Start with your triangle. What triangle has the cosine of the angle equal to 1/2? This one, this one, or this one. Bingo. Now I know I'm dealing with these. And I just got to find the correct location of those. What's this guy deal with? In SOHCAHTOA. Okay. What's another way of thinking about adjacent? Good. You're telling me this triangle is horizontal is 1/2? No. Good. If this is pi, that's 3 pi over 3. I just need to go 60 degrees that way. So 1 pi over 3 this way and 1 pi over 3 that way. If you're at 3 pi over 3, I need to go 1 pi over 3 left and 1 pi over 3 more. This is great. Now you just got to find the right angle, right? So you obviously know it's a tall triangle. What pi over what creates that tall triangle? Figure it out? Yeah? It's okay. We'll just work on it.
Last year they did this for memorize.
That's dumb. That's not going to stay with you. We don't like to memorize. If you memorize things, you're just going to forget. I'm yelling at your previous teacher, not you. Okay? Yeah, I'm yelling at you. Who's your previous teacher? Okay, I'm yelling at her. I'm yelling at her. I'm going to tell her later when I see her, okay? No, don't worry. I won't say you said it. How about that? Okay, ready? Start with my triangle. My tall 30, 60, 90 triangle has the adjacent side of 1/2. The tall 30, 60, 90 is when my base angle is 60. That's the pi over 3. So I know I'm working in pi over 3 land. When is cosine negative? Cosine is negative in the second and third quadrants. I want the 60-degree reference angle in the second and third quadrants, or I want this pi over 3, and I want this pi over 3. How do I figure these out? I start with pi. Pi is 3 pi over 3. I am just going 60 degrees that way and 60 degrees that way. That means I'm subtracting and adding 1 pi over 3 to 3 pi over 3, giving me 2 pi over 3, 3 pi over 3, 4 pi over 3. I'm going to change this up, bottom right, and then we're going to do the tangent ones. I'm going to make this harder. Cosecant equals negative 2 root 3 over 3. Change that. They're my notes. I can do whatever I want to them. Okay? Change the question to that. Cosecant x equals negative 2 root 3 over 3. I'm ratcheting up the difficulty like pretty quickly, guys. Okay? Sorry, but like when you do your homework, there's lots of the easier ones, and then we'll get to the harder ones, and we'll get to the hardest ones. This being your first introduction, we got it.
So you could just divide both sides so you can get root 3. Yeah, you could do like when you flip it, you can just divide square root 3 and get it.
All right, ready? First things first, I flip both sides. Okay. I turn it into sine, but then I turn it into 3 over negative 2 root 3. This seems very, very complicated. But then after rationalizing, I realize I get 3 root 3 over negative 2 times 3. Oh my goodness. Negative 2 root 3 over 3 is the same as root 3 over 2 flipped. So the question really is the same as asking, when is sine producing a ratio of negative root 3 over 2? Now that we have that, we think about our triangle. When will sine give us root 3 over 2? And then we think about location. Which quadrants will we have sine be negative at this angle? Cool. Tall 30, 60, 90. That's at the pi over 3. I need the pi over 3 in the third and fourth quadrants where sine is negative. To figure out those pi over 3s, you could start with 3 pi over 3, add 60 degrees. You could start with 6 pi over 3 and subtract 60 degrees, or subtract pi over 3. Giving us 4 pi over 3 and 5 pi over 3. Cool, moving on. Come up to this top left one. I don't know tangent values, but I do know triangles. There is one triangle out there whose opposite over adjacent gives me root 3 over 3. I don't know what it is. I'm just going to figure it out. You figure it out. I know it's not going to be the 45, 45, 90 triangle. Because in the 45, 45, 90 triangle, if I do opposite over adjacent, I'm going to get 1 because it's root 2 over 2 divided by root 2 over 2. You guys figure out, which one is it? Is it the tall or is it the short? Tell your neighbors. Find the locations of the angles. Go. Which one of these two triangles will opposite over adjacent be root 3 over 3? If you don't know, start doing some math. If I take my short triangle and I do my opposite over adjacent, I get 1/2 times 2 over root 3. That's 1 over root 3. Well, if you know how to rationalize, you know 1 over root 3 is the same as root 3 over 3. So step 1 is to just be able to figure out the tangent of your triangles. Okay, that leads me to finding my short triangle, which occurs at the pi over 6s. So I'm thinking about pi over 6s, and now I'm thinking about when tangent is negative. I know tangent is positive here. I know tangent is positive here. So I need the pi over 6s in the second and the fourth quadrants. Figure them out. Go. What are the pi over 6s in the second and the fourth quadrant? Our test is on Friday, guys. Okay? Just letting you know, like our test is on Friday over today's lesson and last class's lesson. It is the easiest test you'll have all year. You gotta shoot for 90s on this test. Okay? We will do plenty of practice on Wednesday. Next class is a review day. We'll do plenty of practice over this lesson. You have a test on Friday. Okay. Pi over 6 is 5 pi over 6 and 11 pi over 6. Extremes. Extremes are easy to deal with if you understood them the other way around. Okay? But here's where things get complicated, guys. Remember, it's the trig function of an angle. I see a lot of students look at this question, ratio, and they think, oh, cosine of 0. And they say, oh, 0 is over here. The cosine of 0 is 1, so they answer x is 1. No, that's not right. That's not the way we're thinking about it. We're thinking, what angle is the adjacent side or the horizontal distance going to equal 0? It's not what is the cosine of 0. It's what angle, the angle 0, the angle pi over 2, the angle pi, the angle 3 pi over 2. All of your answers to these questions will involve some sort of pi, unless it's 0. The angle when the horizontal distance is 0 is the angle when I just go straight up or straight down and I don't go to the left or to the right at all. That's pi over 2 and 3 pi over 2. Cool. Yeah, so we should be putting plus 2 pi n for these two. But I think I put right above it. Oh, no, plus 2 pi n. Not important until we get to the later problems. Everything on your quiz is going to be from 0 to 2 pi. But I'll show you how that gets complicated in a second. All right, sine of an angle equals 0. When is this? It's not asking you what's the sine of 0. You're finding the angles. Go. Talk to your neighbors. When is sine? What angles are sine going to be equal to 0? Yeah, that's fine. You could have just done pi plus pi n, because pi n includes 2 pi. Yeah, there you go. Okay. When is the vertical length going to be 0? That's when I don't go up or down at all. That is going to be at the angle of 0. It's very important to understand the ratio equaling 0 is different from selecting an angle of 0. The angle 0, the angle pi, the angle 2 pi, which happens to be at the same location as 0, but is a different angle. Those are all the ones between 0 and 2 pi. We'll just start with that. Cool? Moving on. The next set, 4 questions. I don't need all 4. Really just one. They look crazy, looks intense, but guess what? If you just isolate the trig function, you win. Don't try to solve this. Instead, get rid of the 3, get rid of the 2, and then find your angle. Okay, we won't spend time finding the angles. You'll get plenty of practice on that. Moving on. Yeah, we're just going to do that one as one example. We're going to come back to the top 2 because those are the toughest. We'll go to this one. Let's go to that one on the right. The question is not when does sine and cosine end up being opposite, where sine is positive and cosine is negative. A lot of people think, oh, I know sine's positive and cosine's negative in the second quadrant. They know that sine and cosine will produce the same value at the pi over 4. When you have the pi over 4, you got root 2 over 2, you got root 2 over 2. A lot of people will answer this pi over 4. What is this pi over 4? Tell your neighbor, what is that pi over 4 there? Some of you needed to practice finding angles. What's that pi over 4 there?
Yeah, the missing one. Oh, never mind.
Good. Many of you will go at this problem this way, and you'll get that the answer is 3 pi over 4. Okay? However, the question might mislead you. The answer is not just 3 pi over 4. The question is actually asking you when are sine and cosine opposites of each other. You could take the opposite of both sides, and you have negative sine equals positive cosine. One way to show that your answer is not just one angle is actually to do something interesting, which is to divide by cosine. Now we can get into why this is the case. The whole like sine is opposite, cosine is adjacent. Tangent, therefore, is sine over cosine or opposite over adjacent. But if you divide by cosine, you actually turn the original question into this question. When does tangent equal -1? And you realize that tangent is not just negative in the second quadrant, it's also negative in the fourth quadrant. You don't want just 3 pi over 4, you want 3 pi over 4 and 7 pi over 4. Okay? Other questions you're going to see. This guy. Now, this looks eerily similar to this. 2x squared plus x equals 0. If you remember from all of your algebra classes, this is a quadratic. You solve quadratics by attempting to factor. Make a sum a product. Now you have two equations that you could set equal to 0. It is the same idea with this. A lot of you might think, oh, divide by cosine or something, get rid of a cosine. No, factor out a cosine. When we have a product set equal to 0, all we need is one piece of the product to equal 0, and the entire thing will equal 0. What we get are two equations that we have to set up and solve set equal to 0. We have cosine theta equal to 0. We solve that. We have 2 cosine theta plus 1 equal to 0. We solve that. To solve 2 cos theta plus 1 equals 0, we isolate cosine theta. So I have two equations. One is cosine 0. That's my up and down. You have to go through the thought process of why it's your up and down. Don't just copy it down. Many of you will need to struggle before your quiz on Wednesday. When is cosine equal to negative 1/2? Think of the triangle, the 60-degree pi over 3 triangle. Think of the quadrants, 2 pi over 3, 4 pi over 3. You need to be able to get there yourself. Okay, but those are my four answers. I have more than just 2 answers. Bringing us to our last question that will have more than just 2 answers. Okay, we'll practice all these tougher ones a lot on Wednesday, but let's go to this one. Notice there's something other than just x or theta. Now remember, it's a trig function. That's supposed to say trig. It's a trig function of an angle that equals a ratio. Well, let's just kind of change this question to the trig function of some angle equals this ratio. Let's kind of ignore the 2 for now. Now, let's see. How many of you are like already like on top of this? Tell me, what angles is sine equal to √3/2? Who's got it? When is sine equal to √3/2?
Pi over 3.
That's exactly right. The angles are pi over 3 and 2 pi over 3. If you're not there yet, it's okay. You got to get there. Start with the triangle. Look at ASTC to figure it out. Okay. Now, those are my angles. But my angles replace 2 times theta, where theta is what I want to find the solutions for. What do I do to find my solutions if I know 2 times the solutions are what I want for my angle? Tell your neighbors. Divide by 2. Giving me pi over 6 and pi over 3. However, if I want all of my solutions from 0 to 2 pi, I want all of the solutions from 0 to 2 pi. Pi over 6 and pi over 3 are definitely between 0 and 2 pi. But what happened is I took my angles, divided by them by 2 to get my solution. Before dividing by 2, if we thought of adding multiples of 2 pi, what you would find is that dividing this by 2 says, you know what, your solution could be those 2 angles, pi over 6 and pi over 3, but you might have to add pies and increase the amount of solutions you have, which you will work on and learn and perfect while you do your homework. Okay? There's plenty of those. Make sure you get the basics down before you get the tougher things. I promise this needs to be the easiest test of the year.
I saw this problem with homework,
Yeah.
and I see like it has the growth brackets and it gives